Hi everyone, in this video we are exploring AWS Systems Manager SSM, a service that helps you manage and operate your EC2 instances securely without needing direct SSH access. I'll show you how to connect EC2 instances in a private subnet to SSM without using the public internet using VPC Interface Endpoints. Then we'll run a command on all the instances at once using SSM Run Command so you can see how to manage private workloads efficiently and securely. Now let's move to the diagram. Here we can see we have AWS Cloud, Region and VPC. Under this VPC we see we have two availability zones. In each availability zone we have private subnet with EC2 instances in it. To connect our EC2 instances in a private subnet to AWS Systems Manager without using the public internet, we will use three interface VPC endpoints called SSM, SSM messages, and EC2 messages. SSM endpoint will help in core system manager services. SSM messages endpoint will be used for sending and receiving agent messages, whereas EC2 messages endpoint will be used for command and session management. For simplicity, we show a single VPC interface endpoint icon, but in reality, this represents three endpoints needed for SSM communication. Here, inside the private subnet, we can see that while creating an interface VPC endpoint, we will be selecting both of this private subnet, which will create VPC endpoint ENIs in the subnet for its corresponding endpoints called SSM, SSM messages, and EC2 messages in both private subnets. We will be using IAM role with a policy called Amazon SSM Managed Instance Core, which is AWS managed policy, which will eventually be assumed by these EC2 instances in both private subnet, which can be seen from this line. We are calling the IAM role EC2 SSM role. Apart from IAM role, we will be needing EC2 instances with SSM Agent, where SSM Agent, by the way, is pre-installed on Amazon Linux AMI. We need agent because it handles communication with System Manager. Now let's move to the security groups. Here we can see that we are creating two security groups, one for the EC2 and another for our VPC interface endpoints. Security group used by EC2 instance will have inbound rule of none, whereas outbound rule of HTTPS 443 to this IP range. We are using HTTPS because all the communication between EC2 and AWS Systems Manager SSM will happen in HTTPS. Now moving to the security group for our interface VPC endpoint, it will have inbound of HTTPS from SSM demo SG and outbound of HTTPS to this IP address range. Alright, it's time for the hands-on demo. Let's see this in action. Now that we are in the AWS console, let's open VPC. Click Create VPC. Under VPC setting, let's select VPC and more. Let's give this VPC a name. Scrolling down, for the number of availability zones, select 2. For number of public subnets, let's select 0. For number of private subnets, let's select 2. For VPC endpoints, we will be selecting none. Now click Create VPC. You can see we have created our VPC. So now let's click View VPC. We can see under resource map, we have created a VPC called Demo VPC with two subnets in two different availability zones, AP South 1A and AP South 1B. Inside each of the availability zone, we see a private subnet called demo subnet private 1 AP south 1A and demo subnet private 2 AP south 1B. Now let's create security group and role for our EC2 instances. So let's move back to our AWS console. Let's open security group. Click create security group. Give this security group a name. Let's put dot for description, and for VPC, let's select our newly created VPC called demo VPC. For inbound rule, we won't be needing it, so leave it as it is. For outbound rule, let's delete this outbound rule and click add rule. For type, let's select HTTPS. And for destination, let's select anywhere IPv4. Let's scroll down and click create security group. Moving back to this diagram, we have successfully created a security group called SSM Demo SG. Now let's create an IAM role. Let's open IAM. From the left hand side under Access Management, click Roles. Click Create Role. Under Trusted Entity Type, AWS Services is OK. For use case, let's select this drop down and select EC2. For the use case, we can see EC2 role for AWS System Manager. So let's select this option and click Next. We see we got this Amazon SSM Managed Instance Core. Now let's click Next. Let's give this role a name. Now let's click Create Role. Now you can see we have successfully created an IAM role called EC2 SSM role for our EC2 instances. Now let's create EC2 instances in both of our private subnet in two different availability zones. Now let's open EC2. Let's click this launch instance. Let's give this instance a name. Let's click add additional tags, add new tag, give the key name app, and for the value let's select demo fleet. We will be using this key of app and value of demo fleet when we will be running a run command. Scroll down, and for this AMI we will be using Amazon Linux, which has Amazon SSM Agent installed by default. Let's scroll down to the key pair and let's select proceed without a key pair. As we won't be using SSH keys for this demo, in network settings, let's click edit and let's select our newly created VPC. Under subnet, let's select demo subnet private 1 AP south 1A. For auto assign public IP, it should be disabled as we are creating EC2 instances in private subnet without any public IPs. For firewall security group, click select existing security group. Now let's select this drop down and select our security group called SSM Demo SG. Now let's click launch instances. Let's click this instance ID. We can see its instant state is in running. Moving back to this diagram, we have successfully created an EC2 instance in one of the availability zones. So we will be repeating the same steps for our private subnet in another availability zone. So let's move back to this console. Let's open this EC2. Let's click launch instance. Let's give this instance a name. Let's click add additional tags and add new tag. Let's give this key of app and value of demo fleet. Again, I am repeating this that we will be using this key value to select both of our EC2 instance while using run command. Let's scroll down. For AMI, we will be using Amazon Linux. For key pair name, we will proceed without a key pair. For network setting, let's click edit again. For VPC, let's select our demo VPC. For subnet, now we will be selecting demo subnet private 2 AP south 1B. For auto assign public IP, it will be disabled. For firewall security group, let's select existing security group and select SSM Demo SG. And for advanced details, let's click IAM instance profile and select our role called EC2 SSM role. Now let's click Launch Instance. In our previous instance called Demo Server 1, I forgot to add an instance role. So let me go back to the instances. I think I made a mistake. So for this initializing status, this was our second server. So let me rename this to Demo Server 2. You can see its status is initializing. Now let's move to this Demo Server 1 and attach an IAM role, which I forgot previously. So under Actions, under Security, let's click Modify IAM Role, and for IAM role, let's select EC2 SSM Role. Now let's click Update IAM Role. Now moving back to this diagram, we have successfully created EC2 instances, which uses a security group called Demo SG and also assumes a role called EC2 SSM Role. Now let's create this second security group called SSM Endpoint SG for our interface VPC endpoints. Now let's move back to the security group console. Let's click security groups, click create security group, give this security group a name. For description, let's put dot. For VPC, let's select our demo VPC. For our inbound rule, let's put HTTPS as type. For custom, let's select our previously created security group for our EC2 instances called SSM Demo SG. For outbound rule, let's select HTTPS. And for destination, let's select anywhere IPv4. Now let's scroll down and click Create Security Group. You can see now we have successfully created a security group called SSM Endpoints SG for our interface VPC endpoints. Moving back to these security groups, we can see we have two security groups being created successfully. Now let's move back to our VPC console and create three interface endpoints. From the left hand side under Private Link and Lattice, let's select Endpoints. Let's open three tabs for this. Now let's move to the first Endpoints tab and click Create Endpoint. Let's give this endpoint a name. For type, we will be using AWS Services. Scrolling down under Services, let's select for our SSM endpoint. You see we have a service name called com.amazonaws.apsouth1.ssm. So let's select this interface endpoint. Let's click this radio button. For the VPC, let's select our demo VPC. For the availability zone, we will be selecting both of the availability zone. And for the subnet, let's select the available subnet for both of our availability zone. So we have selected both of our private subnet in two different availability zones. Now scrolling down, let's select our security group for endpoint, which is SSM Endpoints SG. Now let's scroll down and click Create Endpoint. Moving back to the diagram, we have successfully created an VPC interface endpoint for our SSM. So we will be repeating the same steps for SSM messages and EC2 messages. Let's move back to the endpoint console. Let's click Create Endpoint. Let's give this endpoint a name. Under Services, let's select SSM Messages. You see we have a service name called com.amazonaws.apsouth1ssm messages. Let's select it and click this radio button. Scrolling down under network setting, let's select our VPC called demo VPC. For our availability zone, let's select both of the availability zone, and for subnet, let's select available subnets for both availability zone. For security group, select SSM Endpoints SG. Now click Create Endpoint. Now let's create our last VPC interface endpoint. Click Create Endpoint. Give this endpoint a name. Scrolling down, let's search for a service. Let's select this service name and click this radio button. Now let's select our VPC. For our availability zone, let's select both of the availability zone. Under subnet ID, let's select private subnets under availability zones. For security group, let's select SSM Endpoints SG. Scrolling down, now let's click Create Endpoint. Let's click Clear Filters. Here we can see we have 3 endpoints with status available. So let's move back to the EC2 console. Here under EC2 console, we can see both of our instances have status check, 3 out of 3 checked pass. Please remember that we have given a tag of key app and value of demo fleet. So for demo server 1, let's select this tags tab and see we have a tag of key app and value of demo fleet. Let's repeat the same process and see for demo server 2, you see we have a key of app and value of demo fleet. Now finally let's move back to our AWS SSM console. Let's open Systems Manager. From the left hand side under Node Tools, let's click Fleet Manager. You can see we have 2 nodes listed called Demo Server 1 and Demo Server 2. So this proves that we have a connection between AWS SSM and private EC2 instances. Now let's open the menu bar from the left and under Node Tools, let's click Run Command. Click Run a command. Under Command Document Search, let's search for AWS Run Shell Script document. Let's select this AWS Run Select Script. Scrolling down to the commands parameter, let's specify a command. So you might be wondering what this command does. It shows host name, so we can see which instance is responding, and also shows uptime, and we are using this separator for readability. Scrolling down for target selection, for tag key, let's select app, and for tag value, let's select demo fleet. These tag key and tag value are exactly the same for our both of the EC2 instances. So we are selecting our EC2 instances by using tags. Let's click Add. For output option, let's deselect this enable an S3 bucket option for our output. Now let's click Run. You can see we have a status of in progress. Let's refresh this. We can see that we have successfully executed our command to both of our EC2 instances successfully. To confirm, let's select our first instance and see its view output. For the output, indeed we can see we have a host name with its corresponding uptime of 34 minutes. Now let's move back to our target and output tab. Now let's view our output for our second instance by clicking View Output. Expanding this output, we can see we have another host name with its corresponding uptime. That will be it for this demo. To reduce unnecessary cost, let's delete our interface endpoints. Let's move back to our endpoints. Let's select all of our endpoints and under Actions, let's click Create VPC Endpoints. Let's confirm. Click Delete. Now let's move back to our EC2 console. Click Instances. Select both of the instances and under Instance State, let's click Terminate Delete Instances. Let's click Terminate. After deleting both of these instances and 3 endpoints, we won't be incurring any unnecessary charges. So in this video, we connected private EC2 instances to AWS Systems Manager without using the public internet, using VPC Interface Endpoints. Then we used SSM Run Command to execute commands securely across our instances. No SSH, no Bastion host, and no inbound access required. This is a powerful pattern for managing private workloads securely at scale. If this helped you understand SSM and private connectivity, give the video a like and subscribe for more hands-on AWS demos. Thanks for watching.